Good day everybody. In this video I'm going to give you a basic understanding of what IP routing is, why we would want and need to use it in the first place. And by the end of this video you'll be able to add and remove IP routes from your PC or routers and ensure that traffic moves between your networks just the way that you would like and need it to. Have you ever run into a situation where you needed to add an IP route to your network but were totally unsure where to start? Please do let me know in the comments below. I'd love to hear from you guys. Earlier on in my career when I was a junior technician, I did find IP routing to be quite an intimidating topic.
IP routing made simple. Why do we need to use IP routing? When you are in an environment where you have multiple physical or virtual networks and multiple routers, you may want to access a machine, a resource, or a printer that resides on one of those other networks, and you will then need to pass through one or more of the routers to find that device. Also, with VLANs being used more and more, you'd also need to use IP routes to move between these virtual networks. So I'm going to take you guys through a very basic example that I'm going to use to explain why and how we're going to handle IP routing.
Alright guys, in this example we have 4 different networks separated by 3 different routers. Our PC, which is located in the bottom right corner here, has an IP address of 192.168.1.100 and it has a default gateway of 192.168.1.254. So let's have a look at the 4 different networks I was referring to. The first one is 192.168.1.0/24. We have network 1 over here. Then we have network 2, which is 192.168.2.0, which resides between router 1 and 2. Then we have network 3, which is 192.168.3.0, which resides between router 2 and 3. And then finally we have network 4, which is 192.168.4.0, which resides on router 3 over here. Okay, so that's our 4 different networks, 1, 2, 3, and 4. And then we have our 3 routers, router 1, router 2, and router 3. Now, firstly, we're going to start with running a basic ping command from our workstation on this network to 192.168.1.254, which is the default gateway of our network, and it is an IP address assigned to an interface on router 1. So what happens when we run the ping command? The ping command request is sent. It reaches this interface 192.168.1.254 and a response is sent back to the NIC on my PC. So that works 100%. 4 packets are sent, 4 packets are received, no issues there. Now we are going to ping 192.168.2.254. That is an interface on router 2. So what's going to happen here is, first of all, on our computer we're going to run the ping command. Our NIC is going to check and notice that this IP address does not reside on the local area network. So the next step is it will then forward that request to the default gateway. Once it gets to router 1 will see it does have an interface attached to it that has that network ID. So what will then happen is that request will be sent to that network ID. And what happens once that request hits this local area network, network 2, the IP address we are pinging does reside on network 2. So we will then get a response from this interface. Okay, in the next ping example, we're going to run a ping request to an IP address that resides on network 3. So we're going to ping 192.168.3.254. Now what's going to happen in this instance is the ping will be generated from our workstation. That IP address does not exist on network 1, so the request is then forwarded to the default gateway. Router 1 will then say, I have 192.168.1 attached to me, I have 192.168.2 attached to me, I don't have an interface with 192.168.3 attached. It will then look at its static routing table and look if there are any static rules or routes that have been set up for traffic that is looking for this network. And in that case, it's going to find nothing and it will simply drop that request. You'll then get a failed ping response. So what needs to happen in this case is we need to add an IP route onto router 1 to tell it what to do with any traffic that arrives that is looking for network 3. Alright, so what you're going to do, the command, if you are running this from a command prompt, would be structured like this. However, we are actually adding this to a router, so we're not going to be running a command line prompt here. But nonetheless, what needs to happen is a route needs to be added that says any traffic that is looking for 192.168.3.0, the network ID, with this subnet mask, needs to be sent off to network 2's default gateway on router 2. So basically what we're saying on router 1 is any traffic that comes here that is looking for network 3, we need to pass on to this interface on router 2. Now because router 2 is connected to both network 2 and network 3, it will know what to do with any traffic that is looking for this network. So what's going to happen then, our ping command will be sent from our workstation. It'll hit router 1. From router 1, it will see this route that's been added to say any traffic that is looking for this network, pass on to this interface here. So that request then lands on router 2. Once it gets to router 2 will say, okay, I've got 192.168.2 as an interface. I've got 192.168.3 as an interface. It knows that this request needs to be sent to network 3. And once that request hits network 3, this IP address will then respond. And the traffic will follow the same route back to my workstation that it took to find the IP address in the first place. And I'll then get a response. Alright guys, so what we're going to do in this example is we're going to run a ping command from our workstation on network 1 and want to get a response from the workstation on network 4. So let's have a look at what would happen if we run that ping command right now. We would run the ping command to 192.168.4, which is an IP address on network 4. That IP address does not exist on network 1, so the request is forwarded to router 1. Router 1 will then say, I've got an IP address on network 1, I've got an IP address on network 2, this request is for network 4. It will look through its IP routes in its routing table. It will not have a static route set for network 4, and it will drop the request. We then get a failed ping response. So first and foremost, we need to add a route to router 1 to tell it what to do with any traffic that is looking for network 4. So what we're going to do is add a route on router 1 to say any traffic that is looking for network 4 with this subnet mask needs to be forwarded to 192.168.2.254. which is an interface on router 2. So we add that route. Let's run our ping command again now. What happens is the ping command is run. It doesn't find that IP address on this network, so it forwards the request to router 1. Router 1 will say, oh yes, I do have a static route for any traffic looking for network 4. I've been told to forward it to router 2. The request then hits router 2. Router 2 will see the request looking for network 4. It will say, I've got an interface on network 2, I've got an interface on network 3. It will look at its routing table. It has nothing telling it what to do for traffic looking for network 4, and the request is then dropped. Again, your ping response fails, even though we've added that route to router 1. So what now needs to happen is we need to add an additional route to router 2, telling it what to do with any traffic that is destined for network 4. So this is what it'll look like. We add a route saying, any traffic that is looking for network 4 with this subnet mask, we need to forward on to 192.168.3.254, which is this interface on router 3. Now that we've added that route to router 2 and the previous route to router 1, let's talk our way through the ping command again. We now run a ping 192.168.4.100. That IP address is not available on network 1. That request is forwarded to router 1. Router 1 picks up in its routing table any traffic destined for network 4 I need to forward to 192.168.2.254. It then pushes the traffic onto router 2. Router 2 has a look at its routing table and sees any traffic looking for network 4 I need to forward on to 192.168.3.254. It then forwards that request onto router 3. Now because router 3 is connected to network 3 as well as network 4, no route needs to be added here. It knows what to do with that traffic. It then forwards the request onto network 4. This PC is located and it then responds. So our loop is now closed. The request is sent, it reaches the destination computer, and the response is sent back. And we now have a successful response. Hey guys, thanks for watching the video. You may also find value in our command prompt video, which is popping up on the screen now. If you did enjoy the content, please give us a thumbs up and be sure to subscribe to the channel so you can be notified of any future uploads and videos as they are released. Until the next time, guys.